Good morning, School of Tomorrow people. You're of all ages and you may be interested in geometry. Why? Because this channel focuses on what? Bucky Fuller's synergetics, which is a geometric philosophy. It's a philosophical language anchored in geometric metaphors, you could say. Now, antiprism, this will be a useful tool. If you can get this installed on any computer, you have a gold mine of wonderful polyhedrons that you can generate with all kinds of parameters. And it's really well documented with lots of examples. There's an album. Adrian has done a really wonderful job with all this stuff. And you can get it to work on a Raspberry Pi. You can get it compiled on a Raspberry Pi. I've done that. I'll show you what a Raspberry Pi looks like if I can get to my VNC viewer. So this is the desktop of a small little tiny computer down in the basement. So 2 floors away, connected by Wi-Fi to the same router, 1 floor away, is this little computer that costs like 40 or $50 or whatever. It's like inexpensive compared to a MacBook Pro, which is what I'm using right now, an older one, 2009. The last 3 videos was showing me on an upgrade path, working to get POV-Ray to compile. It's the Unix version that runs on these non-Windows machines. At least that's the one that Homebrew installs, and that's the one I went through in the last couple videos. Now this is hard to read right now, but what you can see is that I have POV-Ray and antiprism. I don't know if you can see it or not, but POV-Ray and antiprism both living on this Raspberry Pi. But I had to compile them. But that's not, like I say, it's not that hard to do if everything goes according to script. Now on the Mac I had Homebrew. It's a complicated script. Homebrew is written partially in the Ruby language. On the Pi, I didn't use anything quite that fancy, but there's still the make, install, configure, make, install is the process for those familiar. And I'm interested in being one of those helping to pass the torch on that kind of technology. So what's going on in the world right now? It is September the 5th, 2019, and the Bahamas have just been really pounded to a very devastated state by Hurricane Dorian, which is all in the news right now, as is Brexit on the political side. Just to anchor this video in what was going on around the world in a way. Also on Facebook, I'm monitoring the violence in the trucker world in southern Africa because I'm connected to Truckers Without Borders on Facebook. So that's not something in the news, but like I say, with social media we can track stories all over the world that don't necessarily make it to mass viewing television, commercial supported and so on. Alright, so one objective in doing POV-Ray on this particular computer was to be able to regenerate my 4D Solutions logo on higher resolutions. So, you know, much more ready for printing on placards and stuff, given the Lattice Gallery that's opening downtown, the Matrix Gallery, whatever, the C60 focus, Flextegrity focus. So that was one objective in getting a more high resolution, or getting POV-Ray and these Python scripts to work on this computer. So let me wind down this video talking about what this is about. And I haven't put anything on GitHub yet regarding the newest code here. There's a lot at my old 4D Solutions Oregon Curriculum Network website regarding having Python talk to POV-Ray. The technique is you want to get files at the end of the day that look something like this. Now this is not going to color code correctly in Spider, which is the IDE I'm showing you now. Spider knows nothing about POV-Ray, and as long as it's all in black and white, it's kind of readable, but every so often some kind of color coder kicks in and it makes it harder to read, not easier. But this is a POV-Ray file on the left, and it's written in what's called scene description language, which is way more sophisticated and powerful than I have ever learned. I've learned the bare minimum, and that's true with a lot of technologies. We learn the bare minimum, and then on a few we go deep. And then you can add to your knowledge as you need to. You don't need to master A before you go on to B. You need to learn as much A as you need to leverage your knowledge in these other areas and then come back and learn more if you need to, and so on. For example, declaring a union. This means take all the spheres and all the cylinders that I'm about to define and lump them all together as a named object, so then you can rotate that whole object as a unity, and I'm calling it QTET. And what I'm doing here in this code is I'm getting my QRay software, which is at GitHub in the Python 5 subfolder or repo. And this is a POVRay's vector. For those just joining us, a vector and QVector are both in the same module here as classes, and the vector is your standard, pointy arrow with the tail always at the origin, the way I do it. If you want an edge, like in a polyhedron, and you want to actually see, some polyhedra, then you need not vectors, but pairs of vectors. In other words, edges point to, let's get some polyhedra on the screen. So these are generated, this logo is generated by the Q vectors. In other words, we can call them basis vectors. We don't rotate them in order to linear combine them to reach any point in space with 4 tuples. People liken them to the barycentrics. They don't add to 0. They can, though. You can normalize them in different ways, but it's easier to read about them in Wikipedia, watch more of these YouTubes if you're curious about quadrays. It's part of what I call Martian math because it helps us, if we use quadrays a while, to understand better that saying space is 3-dimensional might not be reflective of some deep Kantian a priori insight. It's more of a cultural convention. And 4D, the way Bucky meant it, simply highlights the tetrahedron's topological significance, and 4D connects to quadrays because we use 4 tuples. And that's useful because people are always saying, well, space is 3D because it only takes 3 coordinates. And then I can say, well, space is 4D because if you throw away the negative sign, you can have 4 coordinates do the work. And that's, we can quibble about 1 more digit, 1 less sign, whatever, but in terms of the minimum necessary, is that whole argument really holding water? And can't you, if it's a discrete space, you can serialize it, and with fractals and so on, or higher, or what I'm saying, right? You can take any finite space and address all of its points in any number of ways, so including with single numbers. So Kant is one thinker here, but Cantor is the real thinker here. And what did Cantor write on dimension? And he was pretty critical of a lot of our intuitive notions, greater criticisms than I've usually seen talked about coming from Cantor. We've accepted what math does is it rolls on and accepts this and that. Like from Fuller, they're prepared to accept the dome, but he was just a popularizer of that, and then the jitterbug, but he was just a popularizer of that. As far as the unit volume tetrahedron, that's a tough pill to swallow because they don't want to give him credit for that. And yet it's important, and a whole subculture is continuing to roll along with or without any support from establishments. So, which is what 4D Solutions is part of that. So this is the whole idea. Let me end with a little bit of talk about what's entailed in the Python thing. Getting it to work, right? So I just took my bare QRay, QVector, and QVector and vector, and in POVToys, which is the same file name as I've been using at the 4D Solutions Oregon Curriculum Network site, but now I'm starting to change it because I want to make it work with the QVector. So this is the kind of thing, though. You've got these big chunks of triple quoted text. This is not a doc string. This is triple quoted text. And these are big chunks of that scene description language that I was showing you. I set up the light sources, all things I can play with. And then I have this thing called a template with lots of $signs inside for substitution. And few people who program in Python may even know that there is a template class in the string module that allows a kind of format string substitution that we probably don't need anymore in later Pythons because we do have format string substitution. But in a way it's nice because it doesn't care at all about curly brace syntax. And our format strings in Python, as you know, are all about, or maybe you don't know, but I'll tell you, we have this curly brace syntax for doing what we call format strings, but since scene description language is so heavily invested in curly braces as well, it can be a little bit tricky, and I'll end with some of this trickiness here, to get the standard format strings to generate POV-Ray scene description language. Not impossible, but what you need to remember is if you don't want your string character to be interpreted as the kind of curly brace that you would substitute into in a format string, because I am using dot format at the end of all this. Notice I'm using the trick of just having successive strings, not comma separated and not joined by plus. I don't have any backslash to show that there's a line continuation because this opening paren after write automatically goes with the close paren. I don't have to say, oh, this line continues and put some kind of backslash somewhere. This backslash n is an escape character that says put a line feed. And this double curly brace is saying, hey, you need to just take this as a literal curly brace because we're writing scene description language here. So that'll come out in the wash as a single curly brace. But down below in these two fragments, I'm going to use the Python standard way of formatting strings, which means I want to substitute into these guys, these curly brace things with single curly braces. That's intended because inside there's something called obj object. I made that up. It's not any keyword or anything. And it should have two attributes, name and modifier. And I use the object equals object here, so I got to pass it in with that name. But I also have an environment variable with that name. So this is the way Python passes things by name to, in this case, a built-in method of the string type. All strings know how to format themselves, in other words. So I have a bunch of tests here. Again, I haven't posted any of this because I'm in the process of changing it pretty actively. But what I had to do to get the Q vector to work in polyhedra, which is yet another piece of this puzzle, is, for example, when one Q vector subtracts or negates, actually, when I negate a Q vector, okay, here's the thing. Here's the last little piece of technical Python. I want my Q vector to work with POV-Ray now, which means it has to know things like its own radius, its own color, and both radius and color were not attributes of the bare native Q vector. So rather than rewrite the Q vector or mess with the QRay's Q vector, which I kind of don't want to mess with, I'm going to subclass. I'm going to say take everything in the QRay's Q vector and make that the parent of this Q vector, which the child now calls the parent's initializer and adds other stuff like radius and color. However, the Q vector has an XYZ method that in code already written for translating to POVRay. Like, I use an API already. I already have an idea of how I want to work with the Q vector that precedes how I wrote the code for Q vector, and I always want to be doing stuff like this. I want to be reaching into a Q vector dictionary, calling it up by letter somehow. So just think of all this as a Q vector. And then I want to use .xyz with a subscript to get its x, y, and z coordinates. So I'm treating xyz as if it's like a tuple inside of one of my Q vectors. However, that's not the way I wrote QRays. It has .xyz as a method to convert to an xyz vector, the normal kind of vector we're all used to. So how do I get the two APIs to work? Well, I use the property decorator, and I say in this version of QVector, the child version, go ahead and use it as an attribute. That's what property does. It turns what a method call into just .attribute. On the other hand, it will return basically convert to a vector real quick and return the XYZ coordinates. It's a very fast process. I won't cache these, I'll just do it every time. And the tuple that comes back then is something you can put square brackets next to. So all this language of .xyz square brackets now suddenly works, but only because I've created a property. And finally, when I negate a Q vector, the tendency would be it will return a Q vector of the parent type. Because when you call up to the parent type and you don't, well, I could fix that actually probably. I have ways, I think I might be able to get this to go away in a future version. But right now, if I negate a Q vector, which I do in my definition of, say, a tetrahedron. So when I want the QRays, the inverse QRays, for example, I'll put a negative sign in front of all these Q vectors, and what was happening is I was getting back the parental Q vector, the one that doesn't know about color and radius, and that was messing me up. So I had to do what's called override the negation method in my child Q vector and just have whatever comes back get turned into this kind of Q vector. But this, as I'm saying, I don't think is the most elegant solution. I'll maybe have more to say about that in another video. But let me just end here with what I've been able to accomplish with POVRay. I am now able, on this computer for the first time, to generate pictures such as, of course, the logo, which I've been talking about, which is created from the two QRay, the QRays and the inverse QRays. You can invert them. Makes two caltrops. And then just connect the outer tips of each of those in two different colors, and that's the logo. So this is like two quadray coordinate systems intersecting. Negative and positive universe, you might say. Then I have, I think out of Antiprism, I believe this TET5, but left over. In other words, I generated it as a POV file long ago. That's why you want to get POVRay working on POVRay, they want you to say. Persistence of vision, POVRay working on a Raspberry Pi, because Antiprism, Adrian's program, is going to output POV files if you ask it to. So these beautiful, it doesn't do these super beautiful renderings necessarily natively. It spits out a very sophisticated .pov file, and then you go off and render it. This is another kind of thing that you can get from Adrian's program. Look how good the anti-aliasing is. It's not a lot of jaggies because I did really high resolution for this. Like I say, a primary motivation for getting all this stuff to work is to get higher resolution on this computer. So there's my mite inside a coupler, brand new, just generated yesterday. And also, since I'm here in the photo stream, let me thank Dick Pugh for an excellent talk on what to do in the case of a disaster. In other words, that's our listening. Be prepared. It's kind of like having a survival bag or survival bucket, the kinds of things you might want to put into it. There you go. Now, this is kind of a cartoon version. You'd need more of most things if you really want to last a long time, without any external support. This would be what you'd want in the Bahamas right now, basically. Good luck if you're in the Carolinas. And there's me taking a picture of myself being monitored at the supermarket. This shirt is a Whitworth Pirates, by the way. It's a school that the Quakers have gone to for their annual session, and I bought this in the gift shop. All right, I'll say goodbye, and I just hope you're inspired to check out POV-Ray if you're going down the geometry track, because there's a lot of payoff in terms of what you'll be able to do with it. And working out in that sense of getting things to compile, even if you're doing it sort of vicariously through Homebrew or one of these automated compile installers, Python Wheel or whatever. Good practice, good workout, encouraged. Talk to you soon.